Welcome back everybody. In this video we are going to talk about the Memento design pattern. The pattern itself aims to take some state of an object, extract that state from that object and be able to store it without giving access to that state. It's important to preserve access to the state because right from the beginning, when we do have some hidden state within the object, we hide it for the reason of not being able to allow anything external interact with it, therefore avoiding unexpected behavior. So it's important to preserve and hide that state. As always, if you are enjoying these videos, leave a like, subscribe, and if you have any questions, make sure to ask them in the comment section. Let's dive into this first example to really kind of explain the idea of grabbing the object, when to return it, etc. In my case, I have an example of a player and a piece. So if you know, like a game board where you roll a dice and then you move the piece forward or backwards a couple of spaces. So you can see if we go forward 3 times, we start at 0, we're moving to 3, to 5, to 7, and then we're going back twice, moving back to 5, which was the previous position, and then moving back to 3, which was the previous position. Again, we're moving forward some random times because that's essentially simulation of the dice throw. We move to 5, to 9, and then again, we go back once, we move back to 5. We have the player, which is performing the actions of taking the piece and moving it. And as you move your piece around the board, the player has to remember all the places where the piece was. So if he steps on a square, which tells him go back to the place you've been 3 turns around, and he's like scratching his head like, oh man, I can't remember because I'm a human and I forgot. Anyway, he has to remember how many times he needs to go back. So we have the player, we have the list of position memories. This can be a stack to like push and pop, whatever, it's a list. This will contain a collection of positions of where the piece was throughout the game. And then we are also storing the piece that belongs to the player. We can really have 2 actions here, going forward and going back. Now let's take a look at the piece and some of the things that are happening in there, because you can see the piece is contained within position and there is a valid reason for it. So coming to the position, we'll see that it also contains the class piece. The whole reason for this is to preserve this state here and not let it be usable outside the piece or the position. So we want to store the position elsewhere outside the piece, but we do not want to expose the state. However, we still want to use the state from within the piece and be able to change that state. We'll go over more examples of how you can hide things but expose it to other things in just a little bit. For now, we are just going to focus on the idea of Memento and grabbing that state from outside of the piece, which is a simple concept in and of itself. So we start with getting the position of the piece. As soon as we new up a player, we get the piece, right? We get the position, take the position, and we store the position in memory. We then roll a random number and we move the piece. If we want to go back, we grab the latest position of the piece. We then remove it from memory, so we no longer need to remember it. We can store other directions that we went in or preserve the history. In this implementation, I choose to remove it, and then we set. So we hard write the position into the piece and override its current state. A new piece can be created and we can set the state of that piece, right? So this is not just to change the state of an already existing object. We can also do it for objects that have just been newed up. So you can think of it as like you have a database and you just want to create a new database with the exact same state. You're just taking this thing, snapshotting it, and spinning up a second instance of it. You will obviously need to be a little bit cautious if you're going to be sharing state. Nevertheless, for the implementation of the piece contains a position, so that's its current state. And you will notice one important thing that's happening here. The position itself has a private integer cell. However, from within the piece, we are still able to access it and set it. And this is an important functionality here because we're trying to hide the state from the outside. However, we're still trying to preserve access to it from within the piece. If we want to move, we take our current position, we take the cell property and whatever value is contained in it, and we move the appropriate number of times. And again, just to reiterate, we are accessing a private field. Otherwise, if we're trying to use a position from outside of this scope, we will not be able to access the cell. So if we have the position here, if I try to access the cell, I cannot because it's private. Coming back with the get position and set position, get position returns a new position object. This is so you don't keep sharing the same state of the piece. If you inject it into some other piece and then you move that piece, this piece will stay in the same place because it has two different position objects, right? So this is just the kind of thing that you will need to think about when you're trying to extract that state or when you're trying to inject that state. So in the set position, we take the position that has been supplied and we just assign the value here. Whatever the position is supplied, whenever the piece is created, we get a new position. So I do not assign the reference of the position to the internal state to avoid memory sharing. If I take the state that I have saved and inject it into two different pieces and I start moving one piece and the second piece will start moving alongside it, that's not a good implementation. And just so you're aware, the memento in the memento pattern refers to the position object. It is the state. The memento is meant to describe the state that you're going to store. Just to reiterate, the memento in memento pattern refers to the state that you are storing, preserving, extracting from the object and injecting back into the object. With a grip on this example, hopefully you can imagine and think back to the command pattern where something is just going to send a command that is going to have the action encapsulated in it in order to keep a history and preserve the undos. Instead of keeping track of all the commands, you take the state of the command and you store the state, and then you can discard the command. But then you can bring the command back in if you want to undo something, inject the state into it, so that will be the memento that you're grabbing out of it and putting back into it, and then execute the undo function. So that is how you can use the command pattern and memento side by side. You would be extracting the state from the command that is required to perform or undo the action. All you'd have to do is preserve that state that is required by that action at that time. So keep that on a stack, on a list, wherever you want. Now, talking a little bit, how can you hide that state and not expose it to the outside world while still using it from within the same or separate class, right? You want to keep the state and the thing that is using the state separate, right? It's only logical. Those things are not the same things. They should be separate classes. I completely understand you. The people who have been describing this pattern, they come from the C++ world where you have a friend class. I think that thing exists in VB. Not in C#, however. So let's see what we can do about it. If we have a public class A, we can have a private integer C, and then if we put A as a parameter into one of the methods in A, we are able to access the private field or property on the instance of A, right? So C is private, we're still able to access C as long as the operations or the accessing of the field or property happens within the same type that is supplied. And if we then return the A and try to use it somewhere outside, we don't get access to the state. We are unable to do anything with it. The next example is what we have used. We have some kind of class B, which in our case was position. It has some state, so that will be the memento. And then we have a class that is going to be consuming that state. So we pass the B and we have access to the private variable, right? In the first example, the state and the thing that works with the state are all mixed together. And the degree of separation will really depend on how complex your interaction is and how separate do you actually need it. At that point, you will need to choose it. In this example, we have two separate classes. They're still a little bit intertwined because one lives within the other one, and it is a little bit awkward. The other example solves that problem a little bit. It switches things around. So class D in our case will be this class C here. So if you imagine the piece containing the position state, the class itself is private, so we are unable to take this class or this position outside. We, however, inherit from an empty interface C. We can give it whatever functions we want, really. Nothing stops this interface living outside of the class as well. I've just put it in here for convenience. I don't know, it's kind of only used here so far, so I just put it in here. Nevertheless, the piece contains the position, and it just inherits from an empty interface. So it doesn't do anything. We have this private state within our class. So when we want to perform an action on this private state, we pass in the interface, right? Because that's the only thing that the outside is going to have. We are unable to accept our state or our memento type because it is private. So the outside will never be able to have it. So we pass in a C, something that implements the C interface, and then we're gonna have to cast it to E. The only problem that you can run into here is if somebody implements something else other than the E behind this interface. If anybody else has better examples of how to hide the state, I would actually love to hear it. Leave a comment. Nevertheless, when we want to get the state, we take our E and we return the C, which is the interface. So the outside only receives the interface and they're unable to do anything with the state and affect it in any way that is going to then break how our component is going to behave based on that hidden state. Thank you very much for watching. Hopefully you have enjoyed it. Again, don't forget to like, subscribe if you haven't already. If you have any questions or suggestions, make sure to leave them in the comment section or my Discord server, and have a good day.